Welcome to Module 4. Now in the previous modules, we've covered a lot of concepts that are very important for secure programming. In this module, we're going to start getting our hands dirty. We're going to show you specific techniques that you can use in .NET to provide for secure coding in your applications. So our objectives here to first and foremost understand a very robust strategy for input validation. Now think back to our previous modules. Input validation will alleviate things like SQL injection, cross-site scripting, and a host of other attacks. So this is a very important topic. We'll discuss some very secure input validation techniques, specifically in ASP.NET, using both the core, web forms, and the MVC. We'll learn defensive coding techniques specifically to prevent SQL injection and related attacks, such as cross-site scripting. We'll learn defensive coding techniques specifically to mitigate parameter tampering. We're going to also talk about defensive coding techniques to mitigate directory traversal and related attacks such as output redirect vulnerabilities. So we've got a lot to cover, and it's all very practical that you can take away and use in your applications immediately. First, we have a question. Does your code perform as expected for the entire range of possible inputs? Pause and think about that for just a moment. The entire range of possible inputs. I didn't say the intended or expected inputs. And that's the crux of our problem here. If you have a free-form text field, people can enter pretty much anything they wish. And that provides a wide range of not only errors and mistakes, but intentional attacks. And we're going to have to work on how to mitigate those. So input validation is basically a process where you verify what the user typed in. You want to make sure that it's the appropriate data type, that it doesn't contain SQL injection and similar attack vectors, things of that nature. One of the simplest techniques you can do that does a great deal to prevent a wide range of attacks is input validation. Now, if you don't do proper validation, if you either don't validate at all or you don't do it effectively, you are going to be vulnerable to cross-site scripting, SQL injection, and a number of other attacks. And these attacks are not prevented by firewalls or intrusion detection systems or honeypots or any of a score of other security appliances. It comes down to your secure coding. It's either done well and you can prevent these attacks, or it's done poorly and you're vulnerable to these attacks. It really is that simple. So, what should we be validating? What are we checking for? First of all, data type. If you requested that the user enter an integer number, a whole number, did they enter a whole number? That's the first thing to check. If instead they entered a string or a symbol, you have bad data to start with. Is it an allowed character set? There are certain characters, such as the single quote, that are commonly used in SQL injection. Other characters, such as the bracket for the script tag, that are used in cross-site scripting. You should never allow those characters to be entered, period. What about minimum and maximum length? I asked you to enter a last name no more than 25 characters. Did you enter no more than 25 characters, or did you attempt to enter 50 or 60? Now that's usually not an attack vector, but it will generate an error when I try to put this very large string into a data field that isn't large enough. Do I allow nulls? Maybe I do, maybe I don't. But if I don't, I need to validate that no nulls are entered. Is there a numeric range I'm requesting, for example, between 18 and 65? And is the input within that range? Do I allow duplicate entries? Now again, I'm not telling you you can't allow duplicate entries, just like I didn't tell you you couldn't allow nulls. But it needs to be either intentional, that you wanted to allow these things, or you explicitly prevent them. What about specific legal values? These are enumerations of specific values that you will allow and not. And by legal, I don't mean the law, I mean legal within your programming language. For example, people who use C languages will find that certain characters are interpreted as an escape character, and that's true with C# as well in the .NET environment. Specific patterns, we're going to talk about using regular expressions to search for and either include or exclude specific patterns of input. Now there's two ways to validate, and I suggest you do both. There's client side and server side. Now, there are advocates who will advocate you only need to do one or the other. I am totally against that approach. First of all, client side. That's a great way to validate data as soon as the client enters the data. As soon as someone puts data in a text field and tries to navigate to the next text field, validate that data right then, right there. It's better for the user. They don't want to get several screens through an application and discover that their data from screen 1 wasn't correct and they have to go back and change it. That's not good. And it's better for security. The moment you detect something inappropriate, stop it then and there. Don't let this continue. However, no matter how much you do client-side validation, you may still need server-side validation. There are attacks wherein an attacker can basically make an end run around your front end and send data directly to the server. Well, if you don't have server-side input validation, you have no protection against that. Or users input data and then there are calculations done on that data. After the calculations, after the manipulations done on the client side, is the data still of the appropriate format, structure, size range, things of those nature. So we need to have both client and server-side validation. Now on the client side, fortunately, as we'll see in just a little while, .NET provides a host of controls that will do a lot of this for you. Another advantage to client side is it takes up less bandwidth. In fact, almost no bandwidth, because you're validating right there in the web form or in the component where the data was entered. It's also quicker, both for the validation process and for the response to the user. Server-side validation scripts, they execute on the server, obviously, and so we have to have the data go from the client to the server before it can be validated. This is one reason why server-side is more of a secondary validation. We first of all have the time constraint. Data has to go from client to server and back. Now that's not a lot of time. It happens in less than a second in many cases. However, if you have a multi-user web form, lots of users are doing this simultaneously, increasing bandwidth without a good reason. We also have the issue that they don't have immediate response. There is at least some delay, and it's possible the user might enter 2 or 3 or 4 or 5 text fields, then click a button, then the data is sent over to a server to be validated. Now the user may see that 3 of their entries are invalid. On the client-side validation, you can do it as soon as they enter the data into a particular field and deal with it immediately. Server-side validation is going to consume extra time and bandwidth. It increases server load and network traffic. Now again, I'm not saying don't do it. I'm saying do it secondary to the client-side validation. Client-server input reliability. Client-side validation is not always reliable because, as I mentioned before, an attacker can bypass the client and put things directly into the server. Or it is possible in some cases for the attacker to disable your validation script on the client side. And that's why simply having client side alone is not sufficient. Both sides validating is a robust validation process that's going to mitigate a lot of attacks and make for much more secure coding. We want to implement input filtering on all input. We want to ensure that nothing goes into our application that wasn't filtered, checked, validated, and verified. This is going to prevent malicious inputs. It's going to prevent errors. And there's a couple of ways we can do this. There are methods called blacklisting and whitelisting. Blacklisting refers to I'm going to allow everything except for these values that I know are bad. Whitelisting says I'm only going to allow these known good values. Now, from a purely security perspective, whitelisting is better. Because with blacklisting, there may be some attack vector I don't know about and I didn't block. However, from a user-friendly point of view, the blacklisting is better because I allow anything that wasn't explicitly blocked. You're going to have to look at your own application, look at your users, and determine which is more appropriate for you. So blacklist would have a list of known bad characters. I mentioned the brackets for scripting. I mentioned the single quotes for SQL injection, things of that nature. And you check the input, and if it contains any of these forbidden characters, you stop. You don't process the input. You perhaps send a message to the user indicating invalid input, and you log the event. In case it was an intentional attack, you want to know what IP address it came from and things of that nature. Now, whitelisting, you have a set of known good characters, and only these characters are allowed. But I can certainly envision scenarios where a user might need to enter a character you didn't account for. These aren't common. For example, if you had a web form that allowed mathematical formulas, there might be a mathematical symbol that you didn't include in your whitelist. It's not part of an attack, and therefore it's not going to be entered because it's not on your whitelist, even though it's not part of an attack vector. Now, those are obscure, they're not common, so in most situations you can probably use a whitelist, but you need to understand it is far more restrictive, and you need to first think through how your end users need to use your application. Do they need access to a wide range of characters, some of which you can't predict? In that case, you'll have to go with a blacklist. Regular expressions. I think all programmers are familiar with these. It's a set of expressions that define a mask, essentially, for input, and we look and see, does the input match some set of expressions? Now, fortunately, .NET provides regular expression controls. You can actually, as you can see on the screen here, we have chosen to match a specific email pattern. We know certain things appear in emails, like the @ symbol, a dot followed by a com or net or edu or something of that nature. So we've specifically looked for a pattern that matches email, something at something dot something. And that regular expression will look to see if what was entered matches the email format. If it doesn't, we'll reject it and notify the user, and if it does, we'll accept it. Input validation on web forms. Now, one of the exciting things about .NET, and they seem to expand on this with each new version, is they have a lot of form controls that will do the validation for you, and some will only allow specific input. There are validation controls that can validate on the server side. There are controls that do it on the client side. They allow for custom error messages to be crafted for the user. You might want to tell the user that sort of input isn't allowed. You may want to give them more or less detail. It all depends on your scenario. You're in total control of it. But because these controls are built into .NET, you don't have to write your own scripts for the validation. It's already built in. You put the control on your web form, you set a few properties, and that's it. You're in business. So here are a few you see listed here. Required field is the most simple. If I have 10 text boxes on a form, maybe 8 of them absolutely must be filled in before we can enter data. So I make those required field validation controls. I associate the validation control with the text field, and you can't leave that form or press a button until you've put something in all of those fields. There are also range validation controls, comparison validation controls, regular expression validation controls, custom validation controls, and a validation summary control, which we're going to be looking at. The required field, as I said, is one of the simplest, and you can see on the screen here we have the code for it, and it basically is saying you must have something in the name text field. And if you don't, a message is going to be displayed that says name cannot be left blank. That's pretty simple. You notice this particular one runs at the server. You can choose the run at location, as you can see right here on the screen. Range validation. We pick a specific range. Now in this case, the range selected was between 10 and 20. So there's a minimum value property of 10, a maximum value of 20, and a type of integer. If they enter in anything other than 10 through 20 integer values, they'll get an error and the data will not actually go into the text field. Comparison. We're looking at things like less than or greater than values. We want you to enter an age, and in this case, we've requested the age be greater than 19. So you have a simple control to validate property, the value to compare to, the operator, we want it to be greater than or equal, and the error message. This is a very simple component, and it allows you to compare and ensure that values are within a certain range. Now, regular expression is perhaps the most flexible. Already built into .NET are regular expressions for email addresses, phones, social security numbers, zip codes, things of that nature. But if you're comfortable with regular expressions, you can certainly write your own. And just like the other validation controls, this is attached to a particular control you want to validate, in this case, email. And it has the expression already in there for you. Again, there are some pre-made expressions you can readily use. And then, of course, you can write your own if you prefer. Custom. This is exactly what it implies. You're going to create your own validation logic. Aside from that, it works just like the other validation controls. It's associated with a specific component, in this case, the employee ID. It has a specific error message, but you choose how to go about validating. And you have a specific function that's called that does the validation. This is the most flexible, but of course the most work for you because you have to write the validation. Validation summary control is exactly what the name suggests. You might have multiple components on a web form, and several of them have different validation controls. This will provide a summary for all the validation controls on the page, perhaps letting the user know that there are 3 fields that need to be corrected. It doesn't actually do validation itself. It simply summarizes what the previous validation controls have validated. So instead of the user getting a different message with each component, they get one single message for the entire web form. Now, those are basic validation techniques, and all of your applications should implement these and use them as widely as you possibly can. But let's start talking about specific attacks now. How do we stop SQL injection? Now, fortunately, .NET has so many methods in there that will stop SQL injection that if you simply follow everything we're going to show you, your application should be virtually invulnerable to SQL injection. I can't guarantee any application is perfectly secure, but yours will be as close as it can be. We're going to talk about parameterized queries, parameterized stored procedures, special input characters, constraining input, and least privileges. So let's start with parameterized queries. You see here on the screen SQL queries just simply written as is. This is the wrong way to do it. Frankly, this is why SQL injection works. You can see here that there are values being inserted into this string. The values are user and password. Well, because of that, I might have typed something other than username and password into those text fields. I might have typed in SQL injection. This is a classic example of how not to do your code. So let's fix it. We've done the exact same code here, except now the query is parameterized. What that means is the username and password that we'd like to put into this SQL query are put into parameters, and it's not possible for me to inject SQL injection commands. Now you can see this took maybe 2 or 3 extra lines of code, but it really did a big difference and makes your application far less vulnerable to SQL injection. That's only one technique. What about parameterized stored procedures? Stored procedures are incredibly common. Microsoft SQL Server is replete with them, and most programmers are accustomed to calling them. So instead of simply calling a stored procedure and inserting an unparameterized value, like in this case customer name, we're going to parameterize the stored procedure just like we did the SQL query. For the same reason, anytime we just throw in text that someone put into a text box, that's an ideal place for an attacker to put in some sort of attack vector. Now, our purpose here isn't to make you a master of SQL injection, but I will tell you that far beyond the simple login screen, one advanced SQL injection technique is to call specific stored procedures to execute specific tasks. So in this case, if you use this unparameterized stored procedure, that's an ideal place for an attacker to put in his own stored procedure call that'll be buried within yours. So how do we fix that? As you see on the screen here, we simply changed a few lines of code to parameterize the values we need to insert, in this case, customer name. That simple change that I think added maybe 2 or 3 lines of code here prevented a SQL injection attack. So parameterizing queries and parameterizing stored procedures are the primary ways you can prevent SQL injection. What about special input characters? Sometimes people will put in input that may or may not be a type of character that's normally recognized. We already talked about certain characters that are used in SQL injection. There may be a situation where a user needs to type in a non-standard character. So here we have an escape routine that basically pulls the single quote out and replaces it with a double quote. We literally simply replace single quotes with double quotes. The purpose of doing that is to prevent the SQL injection attack of a single quote. Now, in addition to those techniques, we can apply the principle we talked about very early in this course of least privilege, in this case to the database account. Obviously, your web application has to have access to the database. That's how it pulls data and puts data in. But make absolutely sure that the account you're using has least privileges. It absolutely should never be a DBA or an administrator account. Perhaps it only needs read access. If that's all you need, then that's all it should have. Now, in some cases, you will need read and write access, but whatever you can do to limit access. Put another way, we're giving you all of these techniques to make it very, very difficult, virtually impossible for an attacker to get through your web application. But we're still assuming they might. And so we're still implementing least privileges, so even if our methods are circumvented, the damage done is drastically reduced. Constraining input. Now, we talked about validation before. It's very important to limit input to what you expected. And again, this is going to be true for limiting attack vectors as well as just preventing errors. If ultimately you have a last name field and you're going to put it into a database, and that database column has a length of 40, and you allow the user to enter in 50 characters, and you don't stop it, when you try to insert that in the database, you're going to get an error. Well, why allow that to happen? Let's constrain the input on the front end so we never get to that point. We've talked about SQL injection. Let's talk about cross-site scripting. Some of the same methods will help against cross-site scripting, such as input validation, but also output encoding. When we take output that someone has entered and we're going to display it, let's make sure we remove attack vectors from that. So output encoding, characters are treated as data, and we look at those characters so we can render any unsafe characters as harmless. I talked about the script tag, and we used the example in an earlier module of entering text, perhaps a review of a product. Well, what if a user needs to use the brackets? Using output encoding, we can safely encode the brackets so that they're not a script tag and the user can still use them. So what we're talking about is still use the input validation that we talked about for SQL injection, but now to prevent cross-site scripting, we also encode the output. The HTML encode method, this is going to be your friend. It encodes unsafe characters and converts them. So that bracket that looks like a less than symbol becomes &LT. The other side of that bracket that looks like a greater than becomes &GT, greater than. And we do the same thing with the ampersand and the quote and other characters that could be used in an attack. We use a variety of methods to encode our output so that it's safe now. Here we can see an illustration of this. We are going to write something out, as you might if a user has entered a review and you want to display it. Only instead of just writing it out, we're going to first call HTML encode method, and we're going to pass it the input text so that we can encode that text in a safe manner. Now here we see two examples of the same code, one of which is vulnerable, the other is not. In the first one, we just write the text out. Whatever is in first name, we're going to write it out and hope there's no bad attack vectors in there, no script tags, nothing of that nature. In the second method, which did not even require a single additional line of code, we just inserted inline the HTML encode method and passed it the item we wanted to print out. That protected us from displaying unsafe code and cross-site scripting to the user. There are other methods like HTML encode. The URL encode is used specifically to work against URL manipulation. So there's a URL, it looks like a legitimate link. However, buried in the link or other things. And what we see here is a simple website, example.com. That's what the user thinks they're clicking on. But underneath it, there's actually an attack script. The URL encode method would prevent that. Any non-alphanumeric characters are actually replaced with their hexadecimal equivalent, preventing the script attack. And here we see an example comparing an unsafe, vulnerable code where we simply have welcome page. Then we have the secure version where we're doing the same thing, only we're using the URL encode method. Just like the HTML encode, this doesn't even require additional lines of code in your program. Just the addition of a small method in line in your code prevents all of these sorts of attacks. There's an entire library built into .NET specifically for combating cross-site scripting. We have the encoding library, which we've been talking about already. You have a variety of encoding functions for user inputs that encode things in a particular way. And of course, we have whitelisting available to us. Let's take a look at that library. Now here we can see we're using a default encoder and we're changing it slightly. You notice this is in the web config file, and we're simply changing it to use the system.web.security anti-XSS cross-site scripting namespace. And this allows us to start using those methods in that library. So now we can see vulnerable code where we're simply writing something out to the screen. And then we can see secure code where we're using that anti-cross-site scripting encoder and its HTML encode method. Now there is an HTML encode method we've already seen. This one is slightly altered specifically to combat cross-site scripting. What about directory traversal? We mentioned that before. Well, here we see a great example of vulnerable and secure code side by side. The vulnerable code, we simply take a file name from some query. The secure code requires 2 extra lines of code. It's not a big deal, but here we're using a path object and we're getting the file name and then we're combining it with file information. What we're essentially doing is we're making sure that the path we're directing ourselves to is a good path and not some bizarre directory traversal path that we've been given by an attacker. Here are some additional techniques you can consider to further mitigate directory traversal. Get an absolute path for the file or directory and convert all characters into its normal form for any URI request. Only process URI requests that don't contain file requests. Now that might not be appropriate for all scenarios, but it's a possibility. Make sure that the first n number of characters are the same as the document root. In other words, make sure they're looking in the web root you want them to look in, and the first few characters don't take you anywhere else. If the requested file path is the same as that document root, only then will the file be returned. If they're trying to go anywhere else, we're just not going to honor that request. You should also return an error and say that's out of bounds. Now, let's take a look at the ASP.NET Core, which has secure coding practices for input validation. Lots of stuff built into .NET for you. We've seen some of it already. Now here you're looking at content security policy directives, such as setting the source for all resources, setting script execution, style implementation for cascading style sheets, how to handle image loading, video loading, iframe. All of these very things will set policies throughout your applications to help configure it to be secure. So here we see an example. We're going to restrict loading resources from other domains. So we have a content security policy, and you can see it highlighted here, that basically says it needs to come from our domain. We're not loading stuff from other domains. Now I want to be clear, as I've said earlier, not every technique is appropriate for every application. You might have an application wherein you need to load things from other domains. But if you don't, this is a really great way to prevent that sort of problem. And you can see how that code is done right here on the screen. Encoding user input. Here we can see the Microsoft ASP.NET Web Utilities namespace, and we're going to use a particular package in it, the NuGet package, which allows us to do a little encoding of user input. So here we have open redirect defensive techniques. We're going to do a local redirect. In other words, if someone tries to redirect to some address that's not local, it's going to give an error. And you can see here the code's pretty simple. It's an if statement. If this is a local URL, then go ahead and do a redirect. If not, in this case we're redirecting them to the home. You might redirect them to a page that notifies them of the issue and alerts them that there's been a redirect attempted. That's up to you, but the coding is the same. Disabling X-frames and I-frames. Some people like to use these, some people don't. They are a great way for attackers to go at your website, so if you don't need them, you want to disable them. And here we have a simple X-frame options deny response header. You can see that right there in the image on the screen, and it will immediately prevent any of that from being on your website. Simple as one line of code. Enable cross-origin request sharing. Now, cross-origin request sharing allows access to resources from other domains, and it allows you to bypass the rules you set to prevent that. So if you need cross-origin request sharing, if it has to happen at some point in your application, you can do it properly using this specific library. You can see the Microsoft ASP.NET core.cors package, and it has within it various methods, such as you can see here we're going to allow one specific origin, or we're going to allow 2 or 3 origins. Now, the most wide open option is to allow all origins, which is usually not recommended. Here we're using cross-origin request sharing with middleware. So somewhere in our middleware, we have defined a cross-origin request sharing policy builder class. Now that class is built within .NET, so we just instantiate it here, and we're using it in this case to look at a specific URL to see if we're going to allow sharing with that URL. We continue it here, showing a specific example where we're using allow specific origin. So we're only going to allow this with a particular website we've chosen. Some guidelines. First of all, it's recommended, although they have it in there, to don't ever use allow all origins, because that opens you up to attacks. Specify the origins you're going to allow and don't allow any others. Ensure this is configured to only allow access to the desired page, not the entire URL. Ensure the origin header matches the host header field. Make sure you have an access control max age header. This is set for a time. That means that yes, we're going to allow you to access resources and share them, but only for a period of time. This isn't carte blanche to do what you will at any given time in the future. That's what the age property is for. And make sure we validate those requests both at the server and client ends. You're enabling data to be moved from another URL to your web application. That's a great place to have bad stuff happen, so we absolutely want all of our data validation techniques being used here. Continuing our discussion of directory traversal defensive techniques, you can disable directory listing. So directory browsing, that allows users to view the directories and files of your web application. That can be disabled by default, so they can't do that. Unless you have an extremely compelling reason to allow this, and I can't think of one, I recommend you never allow directory browsing. And you can see it's very simple. If you need to invoke it, you can invoke add directory browser in your configure services. You can also invoke this method in the startup to enable directory browsing, but again, I recommend you don't. Here we can see disable directory listing. You can see the code right here where we're first adding directory browser, and then you see a second piece of code where we're working to ensure that you can only browse a specific path. So if you must allow directory browsing, let's limit that to a very specific path when you've deemed safe. Disabling non-standard content types. You've all seen the HTTP 404 not found error. Well, that's one thing you're going to get if the server just didn't understand what you were asking for. but we need to make sure we go beyond that. The person may be requesting a file type, and for example, you have PDFs they can download. What if they request some other file type? An EXE, a JPEG, whatever. Setting server unknown file types to true enables serving files with unknown types. You shouldn't do that unless you have an absolutely compelling reason. Use file extension content type provider to serve files with those unknown extensions. Again, unless you have a compelling reason, you'll want to avoid this, but they do allow it in case you have a situation where you must do this. Here we can see again code samples, and as I told you at the beginning of this lesson is replete with specific code samples that you can use and implement in your own programming. Secure static files. You have static files like a PDF that you need to serve up to users. What should we do? Well, first of all, make sure the default location for these is inside the www root folder. Don't have them in any other location. Those directories have to be specifically enabled using the use static files so they're accessible to users. Make sure that secure files are stored in separate folders. In other words, if I'm going to enable you to download PDFs, those PDFs are in a folder by themselves. I don't put other types of files in there. That way I don't inadvertently give you access to things I shouldn't. If the root folder is enabled for static file serving, ensure that the web roots folder doesn't contain any metadata or backup files or things of that nature. Set a default home page for setting a starting point. So we're going to put all of our static files in a particular folder that's within www root. We're going to make sure there's nothing else in there, and we're going to make sure that that's the home page for any sort of static files. Now here we're seeing two examples. Enabling static files from a different folder versus enabling them from www root. The problem with a different folder is you've given them access to something outside of www root, and you've started at least the beginnings of the possibility of directory traversal. What about input validation with MVC? Let's start talking about the model state object. This validates fields of any strongly typed model. So it has a name-value pair that has error messages for specific types of name values on your form. The isValid property is a simple property that says, hey, if no validation errors are found, then this is true. If any are found, this is false. Now we see again two code samples, the wrong way and the right way. The vulnerable code with no validation is given on the left. On the right, it just took a little bit of extra code, a little if statement put in here to validate. First, we're going to find out, is this null or empty? Well, that's not valid data. And we're going to send back a user error message that tells the user, hey, we need your name, or hey, we need your password before we continue. Then we're going to check to see if the model state is valid based on whether or not that data was entered. Data annotation. Predefine attributes to validate data you're going to post. Now, ultimately, although .NET hides a lot of the underlying mechanisms from you, most everything you're doing is a post, a put, or a get command in HTTP. What about these posting of data? We have a lot of validation attributes. Is it required? Must it be a specific data type, a specific range, a specific length? Do we allow HTML to be put in here? Do we need to compare it to something? Do we want to use a regular expression? Do we want to exclude something? All of these are possible, and you can see an example of this in the code shown right here on the screen. Now let's talk about using those custom validation attributes. Again, these are the most flexible. They're also the most difficult, and there's only so much that any course can teach you on those because they're custom. You create them however you wish. But there's an example here of using custom validation logic, and we're checking for specific values. In this case, there's a variable called eSalary, and we're checking to see if it's under a certain range, if it's not null, things of that nature. This is your own logic that you would implement based on whatever business rules you're trying to program for. Remote validation lets the client validate against some data that's on the server. So to implement this, you can see the code right here we annotate the model with the remote attribute. That's fairly simple. And this enables the call any action method from the controller on the client side we can call over to the server for validation. We include the validation control in the action method, and you can see that right here. We have a task, code verification is the name of our method, and we have a few strings being passed to it as well as a Boolean value, and that is all validated using the verify code view model method. Sanitize inputs using casting. Okay, we've already talked about a lot of ways to filter input. If you're still not 100% certain the input is safe, you can sanitize it. Casting essentially restructures a variable. You can cast a number as a string, for example. Here we can see vulnerable non-sanitized input. We're just taking whatever was entered, in this case an ID, and we're passing it into our SQL query. Now the sanitize method that you see on the screen now, we first parse. We use the int parse method, and we're going to make sure that ID is an integer. This is the casting I discussed earlier. We're making something an integer. Now, a side note on this, if they passed in something that cannot be parsed as an integer, you're going to get an error at this point. But at least you haven't processed invalid data. You just need to have proper exception handling for that issue. Parameterized queries. We've mentioned these before. It's simply good programming to always use parameterized queries. You never want a query like you see on the screen right now. This is exactly why SQL injection is still possible. Instead, you want to see what I'm showing you on the screen now, where every one of the parameters that are being passed in are first put in as a parameter. That allows us to ensure there are no SQL injection attacks. Here we see the non-parameterized stored procedures that we discussed earlier, and here we see parameterized. Now, as you saw earlier, parameterizing either queries or stored procedures is not difficult. It doesn't really add much to your code, but it's a very effective technique to preventing SQL injection and cross-site scripting. Using the Object Relation Model, or ORM. This is something included in .NET that protects SQL injection using parameterized queries. So here what we have are link queries that query an entity framework. That was introduced in .NET several versions ago, and it specifically uses parameterized queries to fetch data from the database. So here we can see the secure code using link to fetch the data. And you can see how the way this is working, it would be very difficult to enter an attack vector into that. Enabling content security policies, and this is a cross-site scripting defensive technique. By default, ASP.NET with MVC prevents the execution of requests that have HTML in them. You can enable a content security policy to prevent other domains from accessing your website's assets. Defining this policy is restricting other domains from accessing your resources, and here we see a very simple example. All we did in the web config is we added content security policy. We gave it a value with the source. We set it so that scripts and fonts and images and styles are only accessible from within our own domain. The MVC output encoding, which we mentioned briefly before, can be expanded upon. Here we have expressions that are automatically HTML encoded. It allows scripts to be accepted as user input if you must. Now again, if you can avoid this, do so. But if you're in a situation where you must allow it, we can use the MVC output encoding to basically sanitize them. So here we have validate input as false, so we allow some HTML encoding. Here we've continued it, and in this case you can see what we're doing is we're taking the HTML raw of that string that was entered so that we can display it as HTML. And in this case, there's an administrator displaying thanks. You might have a chat window you're developing, in which case you'll have to use these techniques to allow some of the HTML encoding. We see another example here where we're using the allow HTML attribute, and I can't stress enough, this should only be done in limited places where you must. And here you see the difference. By allowing HTML, we actually see the bold tag being presented to the user. HTML encode will encode a string. By default, these template strings are encoded, so we don't have to use HTML encode because it double encodes the string, basically. So here, if we did use HTML encode, and we're already allowing HTML, we're basically doing it twice, but you can see that it took out the greater than and less than tags and replaced them with encoding. MVC HTML string. This is a class that prevents encoding a string. Again, some of these techniques are being presented to you in case you have a scenario where you must use them. They're not the preferred way of doing things. You can see the code right here, and we move to the next screen. You can see using all of the output encoding using the anti-XSS library. So in this case, we're seeing actual screenshots of Visual Studio. So we want to install that anti-XSS library from NuGet, and you can see right here where you're going to install it. We also have to search for it in the Manage Packages and then select it with the Install button. And that's shown for you right here. Now, you may already have this installed in your Visual Studio, but if you're looking for it and don't have it, these instructions will show you clearly how to install it on your machine. And once you have it, you'll notice under References you have these libraries we've talked about, including anti-cross-site scripting and HTML sanitization library. Output encoding using that anti-cross-site scripting class. Again, we're seeing an example here of a vulnerable code versus secure code, and the difference is very minimal. Just a little bit of code placed in there to change from vulnerable code that has not been cleaned, has not been filtered to prevent cross-site scripting, to a line of code that has been. If you must accept data from other sources, you should only accept it from trusted sources. So in this case, we validate our user input parameters against trusted sources. You can see the vulnerable code where we simply take data. Then the secure code where we look at a method called findByNameAsync, and it's going to go check a model to see if this email matches something we already know. Encrypting and decrypting key values. We have a whole lesson later where we talk about encryption, but basically you can encrypt an order ID so that when it is sent across, it's not going to be sent in plain text. And you can see the code right here. It's a very minimal amount of code where we've simply called a protect method to encrypt that one value. We go a little further here where we can view it, and there's a object called a view bag that has our order ID encrypted, and we see the encoding there where we can decrypt it. Very simple code. Now, this isn't the most robust encryption in the world, but it does prevent you from sending sensitive data in plain text. Here we're looking at vulnerable code in a login screen, and you can see we're going to simply check to see if this URL is null or empty. Well, that's nice, but that's not quite sufficient. So instead, we look at the secure code. We're still going to check to see if it's null or empty, but we're also checking to see what it starts with. We're checking to see for various characters that might indicate some sort of directory traversal, things of that nature. We're going to see if it's an open redirect attack based on the characters we see within the URL. So again, the first one simply checked to see if it was null. The second, secure version, checks to see if there are any open redirect inside the URL. Now in this module, the most important thing we've talked about was input validation. Using those techniques that we looked at is going to mitigate most of the attacks from cross-site scripting, SQL injection, and related attacks. We also looked at both client and server-side validation. We really talked a lot about input filtering, and that's the most important takeaway from this message, but output encoding is also a powerful technique. Now, as I mentioned throughout this module, we did give you a few techniques if there are specific scenarios where you have to use code that we normally wouldn't, such as allowing HTML tags. There are ways to handle that, but the preference is that you simply don't allow them.